Hello, this is Umberto and this is the HVAC is my channel. Today we're going to be talking about duct risers part 3 for townhomes, alright? So let's get into it. So in the previous video we were talking about how to have our chase, our risers for different levels, alright? Now we need to see the connection to those risers. So we need it to be more specific based on the sizing. So now everything is very nice in design when we do it little by little, step by step, okay? So in this case, what we're gonna do is we're gonna focus on the second floor. This is the second floor, and what we need to know is from this second floor, since this is the unit, what is the size of this duct connected to the riser? So supply riser, this is the duct. Usually they call it takeoff, right? So takeoff connected to a main duct. All right. Okay. So as of now, it's showing that we need in here 12 by 8. So we're gonna double check on this. Okay. So it says in here, let's do right click. So in this case, 12 by 8 is giving me a velocity of 802. Okay. But now we need to understand, do you want it rectangular? Do you want it round duct? So that depends on the designer, depends on coordination with the architect. It has a lot of factors, okay? But now it's interesting because since we're in the attic shows a lot of ducts that are flexible, right? These are all flex ducts, flex, and all of them are round, right? So flexible ducts gives you more flexibility, but you gotta be careful with installation too. You don't want to have a lot of sags, or you don't want to squish those flex ducts. It has to be as straight as possible, right? But in this case, since all of them are round, I'm not gonna put in here as rectangular, rigid. So we're gonna continue with the flex duct, okay? So what we're gonna do, instead of 12 by 8, we're gonna make it a round duct. And what is it gonna give us? So how do we make this a round instead of rectangular? So in this case, it says duct width 12, duct height 8. So we're gonna put in here 0 and see how it goes, okay? So if we put 0, so it's gonna give us automatically a round duct in here. See, round flexible vinyl, okay? So 10 inches. It's asking me 10 inches, but also the velocity is 980 FPM, right? So the velocity is related with the noise and everything. So you want to avoid so high noise. So either you're gonna have 10 inches or you're gonna have 12 inches for this connection, okay? So why don't we do 12 inches and see how it goes, okay? So automatic sizing, and we're gonna put no, and then hit enter. And then in here it says 10. Let's change it to 12. If it's 12, this velocity is gonna go down, which is personally, it is better. So if it goes down, say 681 FPM, that's the velocity, and that's 12 inches, okay? All right. So in the previous video, I was also mentioning that we have a duct sizer calculator, and I know I owe you guys this video. We're gonna download this ductulator from another website, okay? But this ductulator, or you can always check it in the ductulator, right? In the duct calculator or ductulator. So the way it works is, this is my online calculator, not online calculator, but it's just an application very quickly. I'll show you that in the next video, I promise. So in here, what's the CFM? So that is the tricky game, because in other words, if you want to size with a duct calculator or a ductulator or this online ductulator, you need to know the CFM. What is the CFM that you're going to be having in here? So the issue in Wrightsoft is actually because this is not simultaneous heating and cooling. This is black or white, either heating or either cooling. It's a heat pump, heating only, cooling only, not mixed, right? Not both. So in other words, we need to account for what is the total CFM. So let me explain to you in here the following, okay? I don't want to get this complicated for everyone, but what we're gonna do is we're gonna see how much CFM is going through this duct, okay? See, the total amount of CFM going through this duct is gonna be the total. How much is the total of this unit? This unit has a total of 800 CFM. So 800 CFM minus all this CFM minus all this CFM will go through this duct to the lower levels. Okay, so in other words, what we're gonna have is, let's have what is the CFM in this 1, 2, 3, 4 air devices. Okay, what's the CFM? Do not do this 56 plus 56 plus 47 plus 15, okay, because Wrightsoft takes into account the worst case scenario. So this could be cooling, this could be heating and heating, as we saw in the previous video. Okay, so in other words, what we're going to do is we're going to size it for cooling. So what is my cooling CFM in this case? This is going to be 56, 56, that's all good. Why? Because we go here, see, to the room, and it says in here that cooling design airflow 112. So this is cooling, we're all good. We're gonna do everything in cooling. For the bathroom, what is my cooling CFM? Is it 47? Let's see. Bathroom number 1, my cooling design airflow is 24. So it's not 47, it's 24. Okay, so I made a list already, so that way the video is quicker. So I'm gonna pull this list right here. Okay, see, we have for the owner's bedroom, we have 112. Everything is in cooling CFM. We're in cooling mode. Okay, so now we're gonna go to the bathroom. In the bathroom, what we have is cooling design airflow is 24. So here, bathroom number 1 is 24 CFM. Okay, let's go for the closet. For the closet, we're gonna have 15 CFM. However, 15 CFM is the heating CFM, it's not the cooling. So the cooling should be 7. So in here, closet, I'm putting 7. Okay, now we're gonna continue going on the next side. How much CFM is 1, 2, 3, 4? Okay, so for the bathroom number 2, my cooling CFM is gonna be 11. There we go. And then bedroom number 2, my cooling design CFM is 62, 62, there you go. Now bedroom number 1, my cooling CFM is 49, 49, there you go. And then the laundry room, my cooling design CFM is 31, 31, there you go. Okay, so if you add all these up, all these CFMs, airflows, the total amount is 296, right? You can do that in your calculator. That's not, it's very quick. And 296, okay? So the remaining airflow would go to the floors or levels below, which is the remaining airflow will go to the first floor and the remaining will go to the basement, right? Okay, so what I do in here, for this takeoff 2 means second floor, is gonna be 104, I'm sorry. What is 104? 104 is 800 minus what we already taken to supply all this second level, right? Which is minus 296. See, 800 CFM minus 296. The remaining is 1504, okay? And then keep in mind, what is the mode? Mode is cooling, okay? The mode is cooling because it's not simultaneous, okay? So there you go. And hey, it's very interesting to do it analytically, but we have to use the software too. Let's check what the software gives us. So if we click in this, it tells us in the properties sheet that the heating is 134, and then the cooling AVF CFMC cooling is 503.8, which is 504. See, 504 analytically corrected and then practically corrected. See, 504. Okay, all right, so now we're saying it's going to be 12. Okay, let's check with my ductulator right here. Where's the ductulator? Okay, the ductulator, you can always double check it with the ductulator too. We're gonna pull this to the side. Let's put this to the side, and then gonna put this to the side. What is it? Ductulator right here. Okay, that's gonna move. No, I'm gonna move this to the side then, since he doesn't wanna move. Okay, we're moving this to the side. Okay, what's the ductulator in here? It says like my CFM is gonna be 504. What is the friction rate in here? The friction rate is usually 0.008, and then in here it says equivalent diameter. 11.2, which will round it up only to 12. So see, if you're using a calculator and you want to do it very quickly, oh, hey man, how is the CFM? The CFM is 504. Okay, so he's gonna put the one of the markers at 0.08 inches of water column per 100 square feet, no, per 100 feet, and then he's going to be able to find the equivalent diameter, which is going to give him 11 or 12. So we're going to round it up to 12. There you go. Calculator proved, and then we're good with this sizing, right? Okay, so now what we're going to do is we're going to go to the second level, first floor, okay? So on the first floor, what we have is this, right? But we're not doing the remaining anymore. I want to know how much CFM goes through here. What is the quick way? The quick way is just to click in here and check how much CFM. So if you do this, clicking here, right click, see property sheet. So in the property sheet, you're going to be able to find this. You click in here, no, you click in here. It's telling you in cooling, you're going to have 330 CFM. But why is it 330 CFM? You know what? For everyone, a big advice. It's very important to know how things work. That makes you more professional. That makes you more knowledgeable, right? So 330, why? Because what we've been doing is the following. So we added up, I'm going to just put this a little bit closer right here for the sake of the video right here. Okay, there we go. So what we have is, in here is 330 CFM right here. How? 300 CFM cooling. Okay, we're gonna add this up. So in the kitchen, what's the kitchen CFM? It's 190. How do you know? You click here, it says cooling distance airflow 190. What is the living room? The living room is also cooling distance CFM is 106. In here, living room is 106. What about the toilet? In the toilet, you have the cooling distance airflow is 34, toilet 34. Okay, so we're doing everything in cooling mode. So 1, 2, 3, 4, 5. We're adding all those 3 registers CFMs in cooling mode only. And if we add them up, it's going to give us a total of 330, which is what we have in here, right? 330 right here. What is it? 330, right? Okay, but now we have in here 8 by 8. But in here the velocity says the following. The velocity says this is, let's see, this is, what is it, where is it? The velocity is right here. It says 743, right? So you can easily reduce this number. We can always leave it, but that always depends on the designer, right? So if you want to change this, what we can do is automatic sizing. We can put no. And in here, we're going to put instead of 10, we can put, instead of 8, we can put 10, right? There we go. Or in fact, we can put this 10 and this we would put this 8. Because generally, honestly, you want to keep the height smaller because that's what there is a lot of issues with the architect. The architect will tell you the flatter your ducts, the better. Because imagine if you're having a high duct, then you will need more ceiling space. The higher the ceiling for them, the better. So they don't want shorter ceilings, right? Short ceilings. Okay. So in this case, we're going to have 10 by 8, see? And then it says 594 FPM. However, let's go double check with the calculator in here. What is our calculator? Right here, okay? So since we have the CFM already, that's going to be 330, okay? And then, oh, again, let's go clear units. This is going to be how much? 330. 330, let's put a 0.08, and then see the duct size, let's put 10. It says exactly 10 by 8, and this is conservative. 10 by 8, 10 by 8, perfection. We're all happy, we're all good, okay? All right, so that was the first floor level, okay? Okay, so now what we're going to do is we're going to go to the next level, to the basement. And in the basement, that's going to be actually very quick. So in other words, we're going to have the unfinished basement. What is my CFM? It's going to be 150. How do we know that? Let's click in here. It says in here, cooling design airflow 150. Okay. Now we're going to go to the foyer. It says 24. Go to the foyer. It says 24. So it's foyer. Sometimes they call it foyer. I'm not sure. Okay. So this should be 150 plus 24. We have a total of 174. So for 174, let's check on this duct size right here, this takeoff. Okay. So this should be 174. Right here, cooling, it says 173.7, which is 174. Okay. And then my velocity is 833. So we can reduce that with no issues. Okay, so we're going to keep the duct height smaller. See, that's what they like, right? The architect is happy, everyone's going to be happy. So in here, we're going to put, instead of 6, let's put 8. What does it give us? We give 625. Yeah, we can do it 8 by 8 or even 10 by 8. There you go. It's 500. Or 8 by 8. 8 by 8 or 10 by 8. Let's check with this ductulator too. So what's the CFM? The CFM is, the total CFM in here is going to be 174. And also it's giving me 10 by 6. There we go. So we can make it 10 by 6, right? But however, this duct riser actually is like, it says 10 by 8. 10 by 8. So in this case, I'm just going to go by 8 by 8 to be safe. There you go. All right. So we're going to make it 8 by 8. So it's giving me my velocity and it's complying with everything. Okay. All right. So I hope you enjoyed this video, but on the other video also, we need to take care of the return side. So this is the supply side and it's all taken care of. See, the supply is all good, but now we need to return these ducts. Okay, so we need to really think about what is our strategy for return. All right. I hope you enjoyed this video. Hit the like button. That helps a lot. Leave a comment and subscribe. All right. Thank you so much.